So we're again looking at algebraic fractions, and this is now our second video, and it's one of several videos on algebraic fractions, but this is our second video on how dividing algebraic fractions to form a single simplified fraction. Okay, so these questions are a wee bit harder than in the last video. Just to take you through the method again of when we are dividing two fractions. Three steps here. We've got to KFC, which stands for keep, flip, change. Keep the first fraction the same, flip the second, and change the sign from a divide to a multiply. Then we just multiply the numerators and multiply the denominators, and then we will simplify as necessary. Okay, so we've got this first example here. A minus 4 over 8 divided by 3a minus 12 over 2. So first thing we're going to do, we're going to keep, flip, change. So we keep the first fraction the same, so it stays as a minus 4 over 8. We flip the second one, so we're going to switch the numerator and the denominator, so that becomes 2 over 3a minus 12, and then we change the sign from a divide to a multiply. So now it is a multiplying sum. So we're going to multiply the two numerators. So I'm multiplying 2 times a minus 4, or it doesn't really matter what way you think about it. We're going to use brackets just so you get an idea in your head. So 2 times a minus 4, I have to multiply everything over here by 2, and on the bottom line I have 8 by everything over here. So I've got 8 times 3a minus 12, and again, as I pointed out in the last video, sometimes people put brackets in earlier. Okay, so then I just have to multiply out what I have in this case. So I've got 2a minus 8. Remember, you multiply everything inside the bracket by the term that's on the outside. So 2 times a is 2a, 2 times 4 is 8, so 2 times minus 4 is minus 8, of course. And then on the bottom line, 8 times 3a is 24a, and 8 times 12 is 96. Okay, now I could have done this earlier as well. I mean, I could have realized 2 and 8, I can divide both those by 2, so it became 1 and 4, so that would have stayed the same, and we just multiplied everything by 4. But when we get to this point as well, we can simplify top and bottom just like any other fraction by looking at a common factor of each term. So I mean, in this case, a common factor of 2, 8, 24 and 96 is of course 2. So I'm going to divide top and bottom by 2 just to simplify, because remember, we're trying to create a simplified algebraic fraction. So 2 divided by 2a is 1a, 8 divided by 2 is 4, so I've got a minus 4 on the top, and then on the bottom, divide this by 2, 24a divided by 2 is 12a, and 96 divided by 2 is 48. Okay, and that will be our final answer. There's nothing else we can really take out there. Sometimes people make a common mistake of thinking, well, the a on the top, a on the bottom, but each term would have to have an a for us to remove an a from each of these. Okay, so that is our final answer. Moving on to our second example. Okay, now sometimes when people come across something like this, they do think they're going to have to use FOIL, multiply the brackets. You actually don't, and I'm just going to point something out. Okay, so I've got b plus 3 over b plus 2 divided by b plus 1 over b plus 2. So we're eventually going to multiply, so I'm actually going to put the brackets in. Okay, but because it's a dividing sum, let's do our keep, flip, change. So let's keep the first fraction the same. So it stays as b plus 3 all over b plus 2. There's my brackets. Okay, flip the second fraction, so it becomes b plus 2 on the top now, and b plus 1 is now on the bottom. And the divide becomes a multiply, so I'm multiplying the two numerators, and I'm multiplying two denominators, right? But here's the thing, if I was to rewrite this in another way, b plus 3 on the top, and b plus 2, so b plus 3 times b plus 2, and you know, generally you would use FOIL to multiply that out, but I'm not going to do that, and this is something you should check before you ever would multiply out. In fact, you don't really need to. If you end up with something like this, and one of the brackets is the same both top and bottom, you can actually cancel those out, okay, because b plus 2 is essentially a common factor of both terms, top and bottom. So what I can actually do is I can cancel the b plus 2 brackets out. And what I end up with in this case is very simply b plus 3 all over b plus 1. And that will be that question finished. So just keep a wee eye out for that. Alright, we'll do one last example. Now something like this, we actually have to do the reverse. What we're going to do, because we're going to do our keep, flip, change, and really doesn't matter if do it now or do it later, okay? But what I can do is I'm going to factorize top and bottom of these fractions, okay? And you'll see why. So I'm going to put brackets back in. Again, if you're a wee bit rusty on with any of these algebraic fraction questions on factorizing or expanding, particularly when we're dealing with quadratics, make sure to watch the videos to refresh your memory on how to do that. But if I was dealing with something like this, okay, so the only way I can get an x squared is if I have an x and an x in each bracket. Remember, this is all over 2 and this is all over 4. 10 is the product, 7 is the sum. So again, we'll just speed it up a wee bit. The only way I can get a 10 from multiplying and a sum from 7 is if both are 2 and 5. And of course, there would be plus and plus because everything is plus over here. And remember, this is still divide. And over here, again, the only way I can get an x squared over here is if I had an x and an x. Now I need a minus 5 and a plus 4. So the only way to get a sum of minus 5, or sorry, a product of minus 5 and a sum of 4 is if it's some combination of 1 and 5, but I want a plus 4, so therefore the 5 has to be the positive, the larger number, and minus 1, because minus 1 plus 5 is positive 4, okay? Now, it's key to notice that one of the brackets is the same as these, and you'll see now in a wee second why what happens. So, if I'm now to just keep flip chain, so I've got x plus 2 times x plus 5 all over 2, and flipping the second fraction, this becomes x minus 1 over x plus 5, and this is now multiply. Also the 4 and the 2 I can cancel down, which I'll do in a wee second. Because I've got an x plus 5, both top and bottom of the fraction, and I can rewrite it like I did earlier with this fraction if it was to make it easier to visualize. I mean, on the top I would have 4 times x plus 2 times x plus 5 all over 2 times x minus 1 times x plus 5. Like I pointed out in the previous example, I can cancel out the x plus 5 both top and bottom. Also 4 over 2 same as 2 over 1, so that's 2 times x plus 2 all over 1 times that. Well, that would just remain as x minus 1, so that would be that one. Don't need to put the bracket in the bottom either. I could multiply at the top, but I mean, you can write it like that, or you could write it as 2x plus 4 top bracket multiplied out over x minus 1, and there's nothing more we can really do to simplify that, okay? I'll post a couple of questions to try these, okay? It's important that you're confident with a number of things when dealing with algebraic fractions, your rules of your 4 operations, your fractions, as well as multiplying terms in algebra, as well as dealing with quadratics, both expanding and factorizing. Anything you're unsure about, just ask, but the best way to improve at these is with plenty of practice.